All right. I did add it this morning. after I heard you say, I was like, I should have done that. I didn't think about it. All right, so we're dealing with long division with polynomials. We're going to divide f of x by g of x. So f of x is what our dividend. That's what we're dividing into. Our divisor is x minus 3. So when we set up long division, the x minus 3 goes on the outside, and then we get that old school long division symbol. And one of the important parts of this, anytime you're either doing synthetic or long division, is that you got to have a representative from the highest power on down for both outside and inside. Okay, highest power on the outside is degree of 1, so there's degree of 1, degree of 0. So that one's taken care of. When we look at f of x, we got cubed, squared, and then nothing. So there should be a term that has x on it. There's not one there. So you're going to put a 0 in its place, or 0x in its place. So we got x cubed minus 4x squared plus 0x, and then the minus 5. Having them in descending order is really important. If they're not in descending order, it can be done, but it sure does make it difficult. Okay. So how do we do this? You may remember. No. You got to make the I got to make the exponents match. So we got an exponent of a 1 here. There's a cubed here. And so I need x squared to make that happen. So that goes up top. And I line them up this way. Like I think column wise. I got x cubed here, x squared here, plain x's here, and numbers here. So organization is your friend.
Wait, what did you do?
So what times this leading term gets me that leading term? That's the way you want to think. Don't worry about the minus 3. It really doesn't matter. It's always whatever's in front. Okay, so x times x squared, that's our x cubed. And then x squared times negative 3. So that's minus 3x squared. And I do parentheses and a minus sign because I'm subtracting that.
So how did you define you did negative 3 times x squared?
Basically, I'm just distributing what I put up here to this. Whatever goes up top distributes to what the divisor is or what you're dividing by. Okay, and then we're subtracting those two. The cubes go away. That's what we want to happen. And then we have negative 4x squared minus a negative 3x squared. Yeah, negative, and I'm going to put the 1x squared there. That seems to make it make more sense. And then I'm going to bring down ever how many terms that I have that I'm dividing by. So I'm dividing by 2 terms, so I need one more thing brought down. So I'm going to bring down the 0x. Yeah, I know it's 0x, but it still matters. Okay. Now I look at the front part again. I say, what times this x gets me negative 1x squared? Negative x or negative 1x. And then I distribute that back to the x minus 3. So there's the negative 1x squared plus 3x this time. Parentheses, subtract. And then squareds go away. That's what we want to happen. And then we have negative 3x, bring down the minus 5. What times x gives me negative 3x? Negative 3. So that's negative 3x plus 9. And we're subtracting that. These are gone. Distributing negative 3 back to this. That'd be the negative 3x. Negative 3 times negative 3 is positive. Whatever I put up here distributes to that to get what I subtract off. And then remainder of how much? Negative 14. I know it's a remainder because I can't multiply anything by x and get something that doesn't have an x. If I multiply by x, it's going to have an x on it. So I know I'm finished now. That's my remainder. The way we add our remainder. Yeah, like that. We have the remainder, whatever's left over, goes over what you divided by, and you add it. I always do plus. You may see if you check some of these in the book, they might actually make this minus and then just 14 over x minus 3 is the same thing. I usually do with plus though.
How did you get like know whether to subtract that?
You're always going to subtract. Never add.
So then you just put the same number below it on the left side.
Well, it's coming from, these are not magical, like just a magic appearance. They come from distributing. Like, so here, distribute x squared to x, I get x cubed. X squared to minus 3, that's minus 3x squared. That's where they're coming from. They should be the same number underneath them if I'm doing it right. If they're not, then I can't get it to cancel. Okay? Long division, fun times. Let's do the same problem with synthetic division. We spend most of our time doing synthetic division, not long division. But long division is something that you need. When we get to rational functions, just fraction functions, we will need long division. So gotta have it. So synthetic division, a little bit easier. Setup is the same. If we're going to take f of x, we're going to divide f of x is x cubed minus 4x squared minus 5 by g of x. Same problem, we're going to do it with synthetic division, see how that works. The way I set that up, this is how I draw my synthetic division box. I don't know how, if you had Coach Mac Browser too, I don't know how he does it. This is how I draw them, okay? His may have been, yeah, that, and it doesn't matter. I mean, as long as you got same, it's the same part. So what I do is I put, this polynomial in here. And again, it's just like long division. You got to have a representative for every power of x, starting with the biggest. So we got x cubed, x squared. We need a 0x in there and a minus 5. The synthetic division, you just take all the letters out of it. So it's going to be 1, negative 4, 0, and negative 5. It's the coefficients. You did it in your calculator? Why would you do it in your calculator?
He showed us something on how to be able to.
This is not a matrix. This is not a matrix. This is synthetic division. Now, to get what, I call this the shelf, to get what goes on the shelf, you have to do synthetic division, you've got to have linear pieces that you're dividing by, and that's a linear piece, it's mx plus b. So you take that linear piece and you set it equal to 0 and solve it. So it's a positive 3 that goes on the shelf. Okay, this 3 is that 3 that's there. Basically, you just change the sign of it. Okay. But if there were a number in front of x, you'd have a fraction up there, and so you got to know how that's found. All right. Synthetic division, the way it always works, instead of subtraction, it's addition. And you add 1 plus nothing is 1, so that comes down to the bottom. And then you do your multiplying. 1 times 3 is 3. And then this is negative 1, negative 3. And then that is negative 9. And you get negative 14 right there. And I always box that in right there. The last piece is always your remainder. All right. Bring whatever's the front is, you just bring it down. Then you multiply. 1 times 3 is that 3. Add. Negative 4 plus 3 is negative 1. Multiply. That's the negative 3. Add. Negative 3. Multiply. Add. We got synthetic division. What that creates is the same answer that we got with long division. That it's x squared minus x minus 3 plus negative 14 over x minus 3. That's what we found by doing that division. Because it starts with cubed. If you divide something that's cubed by something that's linear, first degree, 3, subtract exponents. It's always going to, synthetic division only works if you're using linear pieces, so it's always going to reduce the degree by 1. That's always all it's going to do, is reduce the degree by 1 every time that you use it. Okay. All right. Now, what's the purpose in all this? comes down to the factor theorem. Remember theorems from geometry, we use them a lot. There's algebra theorems as well. The factor theorem says, okay, if I do x minus c, we'll call that, c is just a number. It's a factor of a polynomial if and only if f of c is equal to 0. It's kind of paraphrasing what the factor theorem says. What that says is that if you plug in whatever x would equal right here, and it works out to be a 0, then this little piece is a factor of that polynomial because it's basically c is an x-intercept. That's what it boils down to. Factor theorem is a lot more wordy than that, but this is the gist of it. That's what I want you to get. It's the main idea of the factor theorem. And we're going to exploit that by using synthetic division. That if we can run that through and the remainder be 0, then it's a factor. And that helps us break down a polynomial into smaller parts. Okay? So let's answer this question. Is x minus 1 a factor of f of x equals 2x to the third minus x squared plus 2x minus 3? Let's see. Two ways to verify that. One way would be with long division. Another way would be synthetic division. I know synthetic is useful here because what kind of piece is this? It's linear, and that means I can use synthetic division. If it asks me if x squared minus 4 is a factor of it, I can't use synthetic division for that. It has to be a linear piece for me to do that. If it asks me about something with a higher degree, then I've got to use long division. So that's the reason we even try to do long division. It's one of the reasons. There's some other reasons that we'll get to later on. So let's set up our synthetic division. 2, -1, 2, -3. It's the coefficients. What goes on the shelf? Positive or -1? Positive 1. Because x minus 1 equal to 0, be x equals 1. That's where that's coming from. It's always changing the sign of it. It's all you got to really remember. And then you run it through synthetic division. And we get a remainder of 0. That right there, that 0 coming in the last spot, this means x minus 1 is a factor of f of x. Okay. So that means we can factor that polynomial f of x has x minus 1 as a factor, and then what's left over, or the quotient here, is the other part, 2x squared plus x plus 3. So we're taking a polynomial and using synthetic division, breaking it apart. In section 1, we had the polynomial kind of written like this somewhat. Maybe they can factor this a little further. But that's quadratic. We can do some stuff with quadratics. We had a whole section about that in chapter 4, which you know a lot about quadratics. But here we've taken a polynomial, and instead of it being in cubic now, we've broken it into a linear piece and a quadratic piece. So we're taking it and making it into simpler parts. Okay? It's what we're really trying to do with polynomials the rest of the chapter. Okay. Let's look at another one. Our answer would be, to answer that question, is x minus 1 a factor of that polynomial? Yes, it is. This would be the factored form of that polynomial out of that, based on that. Okay. All right. Find all the possible rational zeros and factor f of x equals 2x cubed plus 11x squared minus 7x minus 6. Okay. In algebra 2, you talk about this thing called the rational zeros theorem. Remember P over Q? We're just talking about that in algebra 2. You talk about the rational zeros theorem. The rational zeros theorem says P over Q. P is this number down here. Q is the leading coefficient. Okay. So what you want to do, you can get this list. Right now, we don't know anything about this polynomial other than the fact that it's third degree, so it should have 3 answers. If we solved it, found all the zeros, it should have 3 zeros. We know it's got a y-intercept at -6, but we don't know anything about a factor of it or anything. So the rational zeros theorem says instead of having all the numbers in the world possible, you can narrow it down to a small list. Okay, and the small list is going to come from the factors of P divided by the factors of Q. Okay, so the factors of P, what are the factors of, I'll write that out, factors of P over factors of Q. Well, what are the factors of 6? 1, 2, 3, 6. The factors of Q, 1 and 2, right? I put the plus or minus in there because it could be, negative numbers are factors as well. What numbers go into 6? That's what factor means. It means a number that will go into a number. You guys make it the rest of the day off on. Give it a second. All right, and then I don't know what's not up there, but then you split them up and you do the individual pieces. So you're going to get all of those factors divided by 1. So 1, 2, 3, and 6, and I'll get it back up there in just a second. Then you're going to get all of those factors on top divided by 2. So you get 1/2. 2 over 2 is 1. I already got that one. 3 over 2. And then 6 over 2 is 3. So you've already got that one. So let's see if we can connect it again here. I know. Why y'all got laptops on your desk? Pause the video here. So we get this thing resumed. All right, so our list, dividing all of these by 1 gets us the 1 through 6. 1, 2, 3, 6. Dividing all of these by 2 gets us the 1/2 and the 3 over 2. 2 over 2 is already there, it's 1. 6 over 2 is already there, it's 3. So you don't repeat any of them. So we've got these possible answers that could be the rational zeros for this particular polynomial. So we've got 1, 2, 3, 4, 5, 6, 12 numbers as opposed to every number in the world. It really narrows it down a lot for us. And you guys have the luxury of the graphing calculator, which I didn't have in high school. We had to check those to see which ones worked, to find one that works. I'm not after that with you guys. I want you to use your brain here. So we set up our synthetic division for that polynomial, which is 2, 11, -7, and -6. And then I need to find something that goes on the shelf. So what I'm going to do is I'm going to graph that polynomial with my graphing calculator. Yes. Do what now? Yeah, I started it. Yeah. So we're going to graph this polynomial with our graphing calculator. All right. So go over here. Y equals, that's some stuff I was doing last night. So let's clear that out. We have 2x to the third. And then don't forget with the new operating system, you got to press the right arrow key to get out of the exponents. Then you got to hit a plus sign if you need one. So plus 11x squared minus 7x, then minus 6. Okay, we hit graph, and we should be in the normal window there. We should be able to see some stuff happening. And what we see is where it's crossing the x-axis. That's the important part. We could get, some nice numbers here. This looks like it's 1, 2, 3, 4, 5. -6 works. So we can check that and verify it with the calculator real quick. -6. We hit trace and then type -6 and hit enter. We want y to be 0. That's what we want. And it is. So that means -6 should work in synthetic division and give us a remainder of 0. These are other numbers. Looks like +1 would be 1 as well. We might use that next when we do synthetic division. And then that one's in between. So I'm thinking that might be the -1/2 probably. But we're gonna run them through with synthetic division. I try to avoid using the fraction ones if at all possible, but you're gonna find some of them, that's all they have is fraction answers. They have like 3/2 and 1/2 and -3/2 or something like that as answers. So sometimes that happens. The key here is that you're not just getting zeros, you're getting the factored form of the polynomial. Because if we just need zeros, yeah, the graph tells us what they are. But this one happened to have all rational zeros. They don't always have that. So I'm going to run -6 through on the synthetic division. And we'll use that one first. I just started on the left. And I'm just going to run that through with synthetic. Bless you. And then -1, so that's 6. Be -1, and then that would be +6. And yeah, what do we know? It's a 0 remainder. That's what we wanted to happen. Okay. What that means is that x plus 6 is a factor. Okay. And then we have 2x² minus x minus 1 left over. It said factor that polynomial. Man, that's quadratic right there. Can I try to factor it using our factoring skills? Yeah, I could. Do the x method. -2 had to be -1. -2 and 1. 2x² minus 2x plus 1x minus 1. Group that. So my factored form of this polynomial then is x plus 6, 2x plus 1, and x minus 1. So there's the completely factored form of that polynomial. So once we get down to a quadratic, so if it's cubic or third degree, we do synthetic once, we'll have a quadratic left over. And then we get all of the things that a quadratic has. We can factor it using the X method. We can do all of, quadratic formula if we're trying to solve it, that sort of thing. We get all of those things with quadratics once we get synthetic down to that. So whatever the degree is of your original polynomial, you're going to do synthetic division until you get it quadratic, and then you can do all the quadratic stuff. Okay, so kind of an extension of that. Example E is what are the zeros of f of x from example D. Well, we know f of x is this factored form now, x plus 6, 2x plus 1, x minus 1. We've got it in factored form. What do we do with each factor to find the zeros? Yeah, set them equal to 0. So there's x equals -6. This will be x equals -1/2. This will be x equals 1. Those are the 3 zeros. This one happens to have all real zeros. We'll get to those that don't have real zeros. The name of this section is find the real zeros of a polynomial. So the ones you see here should be real in that case. Okay. All right. Let's rocking out on Whitney. All right. So let's look at a higher degree one. So we started with a cubic. Let's go to something that's 5th degree. All right. X to the 5th minus x to the 4th minus 4x to the third plus 8x squared minus 32x plus 48. So we want to factor and find the real zeros. All right. We want to factor and find the real zeros. Okay, so we're going to do the same thing we did example D and E there, all in one. But we got a bigger polynomial to deal with. So you need to be able to list me your P over Q. There will be questions on the quiz that ask you to list the possible rational zeros. Should be give me points on the quiz and test. Okay, so what goes on the top for P over Q? The factors of 48. What are the factors of 48? 1, 2, 3, 4, 6, 8, 12 goes into it, 16 goes into it, 24 goes into it, and then 48. And then the good thing is that the Q is 1, so we don't really have much else going on. So our P over Q list is just those that are in the numerator, because we don't have anything in the denominator other than 1. Okay, that works out really nice. Okay, now we're going to set up our synthetic division. 1, -1, -4, 8, -32, and 48. Okay? What goes on the shelf, and how can we find one that does? Graph it. That's how you're going to find your first one. Back in the dark ages when I was in college algebra, we had to actually do synthetic division. We just kind of guessed at one we thought might be the right one and tried it. If it worked, we used it. If it didn't, we tried another number. So you got to be careful of that. So graph that polynomial and see where it crosses the x-axis at. So we got x to the 5th minus x to the 4th It's not going to do any good to shut the door. Or I would. All right. Graph that. All right, so we got some interesting things happening here. We see it crossing the x-axis here at -3. What's it doing here at +2? So what do we know about the +2? Multiplicity of what?
2.
At least 2. It's either 2 or 4 for that. So it's 5th degree, so it could be 4 times it works. I don't think it does, but we know it's got an even multiplicity. We know this -3 has what kind of multiplicity? Odd. It's probably 1, but it could be 3. Or 5. Won't be 5 because we got another 0 here. So let's use one of those in synthetic division. Doesn't matter which one you start with. I usually go left to right just because I'm a little bit on the OCD side, so I read left to right because that's the way you're supposed to read in America anyway. So I'm going to start with -3. That's the one that I picked first. It's not quite as special as 2 is. So I'm going to use -3 first time and run that through. And that would be 8. And there's the remainder of 0. So x minus 3 is a 0. So we got a 0 of x equals -3. And then the factor that goes with that, so sometimes it helps to keep track of it as you go, would be x plus 3. So I'm writing the 0 there and then the factor that goes with it. And then at the end, we'll write the factored form. Okay? Now, here's the great thing is that we've broken this polynomial down from a 5th degree to this is now what? 4th degree. So we're going to keep breaking it down until we get it to a quadratic. So we got 2 more terms. What what's another number that I could use with synthetic division? 2. So I'm going to use that. And I'm just going to go from there. We use a positive 2 on the shelf because we know that the graph hits the x-axis at 2. It bounces off of it. So bring the 1 down and run that through. Remainder of 0. X equals 2. The factor that goes with that is x minus 2. But what did we know about 2?
At this time, I need all 7th and 8th graders to report to the gym. I need you sitting on the visitor side of the gym.
Okay.
7th and 8th grade.
So here we have another, we've taken it from 5th degree to the blue line, which is 4th degree, did synthetic again. Now we've got 3rd degree. And we know that 2 has a multiplicity of 2 or 4. We know it can be used more than once, right? So we're going to use 2 again on synthetic there. Because we know when it bounces off the x-axis, that's what that means. So that's how we recognize that. So that's 2, there's 0, and then 0, 4, and that's 8. There's a remainder 0. Hey, now I've got it down. I got x equals 2 again, and that factors x minus 2. And I've got x squared plus 4 left over. Katie? So I've done synthetic 3 times, and I've got it down to a quadratic. So how can I get the other zeros from there? I could set it equal to 0, and turns out though it's imaginary. We know how to do that. Not just I, but 2i. So this section doesn't find that one. The next section does. Okay, this section, the title of it is Find the Real Zeros. This is not real. This is imaginary, complex. So really, you don't have to find that one. We know it's there. We're going to find it the next section anyway. So you know it's there. So you can go ahead and find it if you want to. The factored form, let's write that because they wanted it. So here's our factors. This is where you go back and look at your factors. You got x minus 2 twice. So maybe you do that. And then we have x plus 3 once, right? And then, technically, you have that. There's our factored form. And then maybe we write here the zeros. X equals negative 3, 2, with the multiplicity of 2. And then we know plus or minus 2i's there too. We'll just go ahead and list that because we know that. We're advanced. We're ahead of the game. That's the section, guys. That's it. I mean, it's that process. You're going to do synthetic division until you get it to a quadratic. And then you've got all the tools for a quadratic that you should have. Because each time that I do synthetic division, it's going to reduce the degree by 1. So this time, it went from 5th to 4th. And then this time, it went from 4th to 3rd. And from 3rd to squared. That's every time you do synthetic, it goes down by 1. Okay? So tomorrow...
When the bell rings in just a minute, I need grades 9 through 12 to report to the gym. 9 through 12 will need to sit on the home side in the gym.